All right, welcome back. I'm going to go through this limiting reactant problem, as well as, it's theoretical yield, and then it's got a percent yield question. So we're just going to go through it, see what we get as practice for the exam. This is in the Chapter 4 unit handout for Chem 111. So we can just start off by reading through the question because that is half the work, right? So, acetic acid can be made by reacting formaldehyde with oxygen. All right, I assume that is what the formula reads, even if I don't know these molecules. Also, this should be an arrow. Sorry about that. Formatting issues. So I'm reacting acetic acid I'm creating acetic acid by reacting formaldehyde with oxygen. I can start with 20 grams of formaldehyde and 10 grams of oxygen, and I need to know which is the limiting reactant. Okay, the good part about these is I already provided you with the molecular weights, right, the molar mass, and I didn't put anything in weird words, so you don't have to determine, oh, well, what's formaldehyde, what is CH3CHO, right? I told you what you need to look for. So we're obviously looking at the reactants here, which one is limiting, and I have taught this several ways. I'm pretty sure it's been taught to you guys like 3 different ways. But honestly, we're just going to go through it, what I think is the easiest and what will support our dimensional analysis skills, right? So all I'm going to do is pretend like both of them are the excess reactant and see what I get. I'm going to see how much acetic acid I can produce. So I'm going to go from grams of reactant, convert it into moles of reactant, then convert to moles of, right, acetic acid. So that's our product. And I will finally convert back to grams of acetic acid. Okay, that's the flow chart. So I'm going to start with formaldehyde because that seems to be the easiest. I have 20 grams of it. 20 grams of CH3CHO. And I need to turn this into moles. So I know that to cancel units, I've got to have grams on the bottom, but what am I even using here? Right up here, guys, right up here. The molar mass, okay? So 44.05 grams of CH3CHO goes on the bottom. And I just have 1 mole on top, okay? That'll be the first conversion, and that will give us our number of moles. I'm going to keep going with this, and we're just going to cancel units along the way. So at this point, I have moles of formaldehyde, and I'm at this step 2 here. I need to get it to moles of product. To do that, I need to use a mole ratio. I'm going to write that on the left here. Mole ratio. What the hell is heck? YouTube, don't flag me. What the heck is that? The mole ratio is just going to be how many moles of this reactant do I have to moles of product. I have 2 moles, 2 CH3CHO for every 2 moles of acetic acid. 2 CH3COOH. Amazing. I'm going to need to find a mole ratio for oxygen as well. So oxygen has no coefficient. That just means there's 1 mole of O2. And again, it's the same product, so 2 moles, and it should say moles here, CH3COOH. That's what I'm going to use here to convert, okay? I'm going to convert between moles of CH3CHO and moles of acetic acid. And I'm going to use my mole ratio doing it. So, come over here. I'm going to put, 1 mole CH3CHO so we can kind of see what needs to go on the denominator here. I am going to need my reactant on the denominator, so 2 moles CH3CHO, 2 moles CH3COOH. And you'll say, but Paige, wait a minute. Like, it's 2 to 2. Can't we just reduce it 1 to 1? Sure. It's not going to make a difference in the calculation anyway. Doesn't matter. Definitely include it in a step, though, because not all of them are a perfect ratio. So don't forget to do it. Just understand that you don't have to multiply and then divide by the same number. So at this point in the reaction, we have gotten moles of product that we need, right? And I just need to convert those moles back to grams right over here. And again, I'm just going to use the molar mass. It is provided in the question. It is 65.05 grams per mole. And if I have moles up here in the numerator, I must have moles in the denominator. So I'm going to put 1 mole CH3COOH. And then on top will go that, 65.05 grams CH3COOH. So this is the full formula. This is exactly how it should look, and it's going to tell us our theoretical yield if I go based off the 20 grams of formaldehyde that I have. And of course, just give me a minute because I have to put this into my calculator because I didn't do it sooner. Sorry, guys. Divided by. Lovely, lovely. All right. Looks like I'm getting about 29.5 grams of acetic acid. So now I know what happens when I, try to predict product based off formaldehyde. Let's do it with oxygen, okay? So I have 10 grams of O2. I need to turn this into moles. So I know, and kind of just follow the flow of what we did up top here, what we did up there. I know what 1 mole is going to have to go here. And then I need the molar mass of oxygen. Now, I know I had initially stated incorrectly in lecture that we would not need our diatomic mass. We totally do. I was mixing that up with another concept, and that's on me. I deeply apologize for any misunderstandings. But we will need the diatomic mass of O2, and it is provided in the problem up here, 32 grams of O2. Grams cancel, right? Grams cancel. I end up with moles. Now again, we're reaching the second step here where I'm converting from moles of one thing to moles of another. And so I would like to redirect you, of course, back to the mole ratio. Wow. So if I want to get rid of moles of O2, I'd probably put that on the denominator so it will cancel. And then I put my 2 moles CH3CHOOH on the top. Fantastic. And then the last step is just converting these moles back to grams. And again, if I want to get rid of moles, I put it on the bottom. And my grams will just be literally the same exact, the same exact molar mass of our product. So sorry about that, guys. My brain's like glitching. COOH. Looks like a D, LOL. Okay, so if I calculate all this out, and of course I haven't actually done it, so times 65.05, amazing, divided by. Awesome. So I'm getting 40.7 grams of CH3COOH. Okay. So I look at these products and I say to myself, well, which is the limiting? It's going to be the one that produces less product. This. Fantastic, which means if I come over here, I wish I had more colors on this palette. If I come over here, formaldehyde is the limiting reactant. Congratulations, we did it. And I've also answered another part of the question, right? What mass of acetic acid will be produced? I've already answered it. It's 29.5 grams of acetic acid. Amazing. The last part of this problem is, what is the percent yield of the reaction if it only produced 8.44 grams? And I know that's a very small amount compared to what we got, but it doesn't really matter what the number is. It just means, if it's a really poor percent yield, I think I said percent error a minute ago, it's percent yield. If the percent yield in actuality is very poor, it just means you did your experiment really poorly. So it's totally possible. We're just going with it, man. So percent yield is going to be our actual yield over our theoretical yield times 100. So I can just plug everything in. My actual yield was that 8.44 grams. My theoretical yield was 29.5 grams. And I'm going to multiply that all by 100. And again, I don't have the answer key in front of me, so just give me a minute. Okay, looks like I get a 28.6% yield. That is absolute and utter trash. But that's okay, because all of the math is correct. All right, I'd say this is definitely the easiest way to do these limiting reactant and theoretical yield problems. Kind of reinforces the whole theoretical yield stoichiometry as well. I know I taught it several different ways. You're welcome to choose whatever way you want to do it, as long as you're getting the right answers. Let me know if there are any questions. Email me, and study hard.